Alright guys, for credit recovery, I'll be going through my classroom notes for astronomy just at a much quicker pace, just to hit the highlights. So to start off with, I just want to talk about, something basic like water. Water is something we interact with every day here. We know so many facts about water. We know what elements make it up. We know its boiling point, its freezing point. We know its density, different states of matter it can exist on Earth, as well as other things. We can conduct experiments on water, and this is why we know what we know. There's a process called electrolysis, which told us which elements it was made up of. And we can do other tests, obviously, like, freeze it. Watch the thermometer go down and watch the thermometer as you reach boiling point. So, you can find out these facts simply because we can interact with the substance. We can see capillary action, surface tension, etc. We know a lot about water because we can interact with it and we can experiment with it. But when we get to things in outer space, we can't do that. We can't directly interact with the sun, for example. However, we do know a lot of facts about it. We know what elements make it up, mostly hydrogen and helium. We know its surface temperature as well as its core temperature, its relative mass. But did we learn about things in outer space the same way that we learned about something like water? Absolutely not, because again, we can't experiment on the sun and we can't interact with it directly. And so we know what we know about things in space because we study radiation. So it's kind of an indirect way to find out many different things about outer space. So here we're going to talk about radiation in depth. Radiation is energy. It can travel through empty space, which is unusual because most things require what's called a medium to pass through. Sound, for example, requires gas particles in order to propagate through, but if I were to talk in outer space, my voice would not carry because, again, sound waves can't travel through empty space. Radiation, however, can. And so as we look off into the distance and we see starlight, that is radiation energy that's traveling through nothing to get to us. So radiation travels in the form of waves, and there's kind of a spectrum you should know. Radiation ranges from radio waves, which are very long, microwaves, infrared waves or light, we're getting a little smaller here, visible light waves, which is all the colors of the rainbow, Roy G. Biv, you might remember, UV light, X-rays, and the smallest wavelengths are gamma rays, and these are very, very dangerous. So you need protective gear for X-rays, for example, and gamma rays, good luck protecting yourself against those. So how is one type of radiation, like microwaves, different from another, like visible light? It's all about wavelength, which is literally the measurement from one spot of a wave to the next spot in the adjacent wave. Radio waves are relatively long, whereas gamma rays are extremely short, and actually these have higher energy and are more dangerous as a result. One thing that you'll be quizzed on in some of these is the order of the spectrum. So you should know this in order from longest to shortest, including in the center here where we've got our visible light. So of the visible light, the colors we can see, red is the longest wavelength, violet would be the shortest of the visible light, and you get shorter and shorter beyond that. Okay. So spectroscopy is the study of radiation with the use of what's called a spectroscope. And so it uses a prism to separate incoming light into its different wavelengths. Which tells us a lot about different materials. So what are the key things that you should know that we can find out in studying radiation? Well, using spectroscopy to study radiation from space allows us to know three key things: the temperature of objects in space, the composition of objects in space, in other words, what is it made up of, and how is the object moving in space? Is it moving away from us, towards us, fast, slow, etc.? you can learn more, but those are the three key things that we focus on here. So spectra is the plural of the word spectrum. Um, we will look at a few different examples, but really kind of you'll see these two examples of emission spectrum, where it's kind of like a lot of dark with some bright lines that pop out at you, and absorption spectrum. And so this is kind of the result of a spectroscope, and you can read these and interpret them. I'm just going to skip ahead here. So this is an example of an emission spectra, and it can tell us what something is made up of. So when something's burned, every element produces a spectrum with a unique set of bright lines. It's kind of like its fingerprint. So hydrogen would only look this way. No other element would produce these same sets of lines. Mercury would produce this set. Again, no other element produces that, etc. So it's kind of a cool activity to try to figure out what's in something. And hopefully you can see this okay from your end, but let's say you had an unknown emission spectrum like this one. You're trying to figure out, okay, what is in this material that's burning in outer space? What you would have to do is compare it to known spectra. So these are like things that you could like look up in a book, for example. And all you have to do is line it up next to these and see, do they match up perfectly? So I know right away that it can't be sodium because I don't see this yellow line right here. I also know that it can't be calcium because it's got all these lines and I don't see them in here. Every line present in the spectrum should also be in the unknown if it matches up properly. As I'm looking here, I think I see the match. It's got to be SR, which stands for strontium. None of the others match up perfectly, and so I know that it's really a material that's made up of strontium that's producing this. The same can be made with an absorption spectra. Basically, it's kind of like the inversion where we've got, this bright background with omitted lines. It means that, clouds or something like that have absorbed the wavelength and so they're missing. But it's still read the same way. Right away, I hope you notice that it matches up in the same locations as the hydrogen stripe. And so right away I know hydrogen is the object that has, or is the material that's been kind of absorbed by a cloud. Mercury, neon, nope, they don't match at all. I have other examples here, but maybe I'll just kind of save it for the quiz now that you kind of get the concept. Let's see here, skipping ahead. I'm going to get to motion on the next lesson, so I'm going to stop here and you should have a quiz to follow.